What's up, guys, and welcome back to Math with McKay. All right, guys, we are still focused on rates and unit rates. All right, remember, when you're writing a rate, you have to put the words on there. So if we're talking about the ratio is typically just going to be the number. So we're going to say a ratio of 4 to 5, right? But now when they specifically talk about 4 pretzels for $5, you have to put that information on there so that you know that it is a rate. So if you go into your student workbook, we are on lesson 17 on page 181. The first example says, or the direction says, given a rate, you can calculate the unit rate associated ratios. Recognize that all ratios associated with a given rate are equivalent because they have the same value. Remember, value just means that the ratio is simplified. It has its smallest form. There is no other number other than the number 1 that will go into both the numerator and the denominator. All right? So the first example, it says write each ratio as a rate. The first one says the ratio of miles to the number of hours is 434 to 7. So all we would do is write the rate based on that. What we're comparing, first thing you want to write is the words, right? Write out the words. So we're talking about miles to hours, right? So we'll say miles and then fraction bar hour. Now we can go ahead and actually put those numbers that are associated with the miles and the hours. They said that the ratio of miles to hours is 434 to 7. Now they went in the order that they talked about. We talked about miles to hours, so 434 would go first, and then we would have 7 hours. All right? The next example says the ratio of the number of laps to the number of minutes. So again, you would write out laps first, because that's what we're talking about, and then underneath, minutes. Then you go ahead and you actually put the numbers associated. They said the ratio of the number of laps to the number of minutes is 5 laps to 4 minutes. This is what we call a rate. We are taking the information that they gave us, the ratio that they gave us, also using the words associated with that particular ratio. All right? So if we look at example 2, it says complete the model below using the ratio from example 1, part B. All right? So the first thing they want us to do is just write the ratio, right? So the ratio would just be 5 to 4. That's the ratio. Notice there are no words or anything along those lines, all right? Then the next thing they want you to do is write the unit rate. This is the smallest form that this particular ratio would be. The only number that goes into both 5 and 4 is 1, all right? The next part says write the rate. You use the ratio that they gave you and then put the words along with it. Now we see the difference between the 3. The ratio is just the number, right? The unit rate is written in the form of a fraction, the smallest that fraction would be. The rate is actually using the words. What are we talking about? 5 laps compared to 4 minutes. All right, so now we're gonna flip the page and go on to page 182. On page 182, we're gonna go to examples 3 through 6, and it says Dave can clean pools at a constant rate of 3 pools for 5 hours, okay? So it says, what is the ratio of the number of pools to the number of hours? Remember, the ratio is just the numbers that are being used. So all you have to do is write out the ratio, which in this case, they said 3 pools for 5 hours. So the ratio would be 3 to 5, okay? Part B says, how many pools can Dave clean in 10 hours? We know that the rate that they gave us was 3 pools for 5 hours. They want you to create an equivalent ratio now that has a denominator of 10 hours instead of 5. So your question to yourself is what am I doing to the number 5 order to get 10? How am I going from a smaller number and increasing that number to 10 in this case? So 5 is smaller than 10. So we're taking this smaller number and we're making it larger to make it 10, right? So what am I doing to 5? When we're creating equivalent ratios, the only two operations that you're going to use is multiplication or division. If I'm going from a smaller number to a larger number, that tells me that I'm multiplying. But if I'm going from a larger number to a smaller number, then I will be doing the opposite, which is dividing. So in this case, we're going from a smaller number to a larger number. So when I do that, I'm going to multiply by the same number. So I know that 5 times 2 gives me 10. So because I multiplied my denominator by 2 in order to get 10, I have to do the same thing to my numerator in order to get my new numerator. So then we say, well, what is 3 times 2? 3 times 2 gives me 6. So we're also going to put the words up here. So that means we could clean 6 pools in 10 hours. All right? They are equivalent to each other because if I were to take 6 tenths and simplify it, it's going to simplify down to 3/5, which means that they are equal to the same exact thing. So then the next question says, how long does it take Dave to clean 15 pools? So what we're doing is throughout this, we're creating equivalent ratios. So now we're going to use the same information that we started off with, right? But now the difference is that we don't know how many hours it's going to take, but we do know how many pools that he can clean. So we're now going from 3 pools to 15 pools. Same concept, right? We're looking at this smaller number and trying to figure out how am I going from this smaller number to this larger number? What am I doing to 3 in order to get 15? 3, remember we're only using multiplication or division. From a smaller number to a larger number, that means I'm multiplying. From a larger number to a smaller number, I would be dividing. But in this case, we know this ratio. This is completed. I have 3/5. This side is not completed. We are missing our denominator. So we need to figure out what the denominator is. So I'm saying, well, what times 3 gives me 15? 3 times 5 gives me 15. So because I multiplied my numerator by 5 in order to get 15, I must do the same thing to my denominator to get my new denominator. So we say, well, what is 5 times 5? 5 times 5 is 25. The denominator's unit was hours, so we're going to put hours along with this. All right? So you have to pay attention to what information they give you and what information you're looking for. In this case, the first question, we were given the amount of hours where we could work, and then we try to figure out how many pools we were looking for. And the second question, we were given the amount of pools, and we had to figure out how many hours we could work. All right? So with these questions, you want to make sure that you're just paying attention to the details that's given. So now you guys are going to have an opportunity to practice some questions on your own.